Hey there, Calc kids. Today we're looking at 4.2, the mean angry value theorem. It's actually not angry. It means average. Okay. What we're going to look at is the mean value theorem, what it actually means physically, how to tell if something's increasing, decreasing, and other consequences of being mean. And we're going to talk about why it's really important. Okay. Here it is. The mean value theorem. Noteworthy. This says you have a continuous function on a closed interval from a to b, and it's differentiable at every point from a to b. And it says if you find the average rate change, the slope from point A to point B, at some point along that line you have that exact slope. That means your derivative at some point equals the average rate of change. What's that all mean? What's it mean? That's a good question. Mean? What's it mean? Mean? Not meme. Mean. I should have a whoever brings in the best calc meme to me will get a prize of some sort. Probably pride. Alright, let's look at this beast. So we have a function, f of x equals x squared, right? That's a function. And we want to prove that it satisfies the mean value theorem from 0 to 2. Okay? And so we have to find where f prime of some number equals the average rate of change on the interval. The function is continuous and differentiable from 0 to 2. Okay, so I'll let you guys write that down. Ponder. Don't Christian ponder. Okay, so we have point A is 0, 0. Okay, it's right here. And if you need to find this y coordinate, what you have to do is plug in your 0 into your function. You know, f of 0 is 0 squared. Okay. And our point B is 2, 4. Because f of 2 is 2 squared, which is 4. Okay? Okay. Now what we have to find is this beast right here. So this is my f of b. This was my f of a. Okay? So we do our 4 minus 0 all over 2 minus 0, which is 2. So that tells me this is my average rate of change. Okay? That's the slope of this line right here from A to B of this function. That's the average rate of change. Okay? Okay. Okay. So here's what we have to do next. We have to find our f prime of x. Well, the derivative of x squared is 2x. Okay? So we take our derivative and we're looking for when does it equal our average rate of change. So we take our 2x and we set it equal to our average rate of change, which was 2. So that tells me when x equals 1, my derivative equals my average rate of change. So I take that 1 and I plug it into my original function. And it's 1. So that tells me at the point 1, 1, x value, y value, my slope of my derivative is 2, hence the mean value theorem works. Okay, gotta check. I am telling you my hair's ridiculous today. Okay, let's talk about increasing function, decreasing function. Okay, if f is a function divided in the interval I from x1 to x2, if x is increasing, it means every point gets higher and higher on the interval. Okay? If it's decreasing, it means every point is lower and lower across the whole kit and caboodle. Okay, so I don't like this definition. If you didn't write this one, that's fine. Here's the best way to say it. Let's say you're continuous on the function from a to b and differentiable. If your derivative is always greater than 0, you're increasing. Okay? If your derivative is always less than 0, you're decreasing, because it means your slope's always going down. And the other one means your slope is always going up. Okay, so this is how we're going to tell if a function is increasing or decreasing. Okay? So write down this definition. This definition is good definition. This is good. Okay, so we have a function. When is it increasing and where is it decreasing? Good question. Okay, so the first thing I need to do is take my derivative. 2 to the x third, so we get 6x squared minus 12, right? And to find out where I'm increasing, I take this 6x squared minus 12 and I set it greater than 0. Not or equal to, greater than. Okay? So I add a 12, add a 12. We get 6x squared greater than 12. Divide by 6, x squared is greater than 2. So we get x, because we square root both sides. Okay, now this is where it gets a little bit tricky here. Okay, so we divide by 6, and we got that 2. Yep. So now we square root both sides, right? Now we gotta ask ourselves, when you square root, you get two solutions, right? You get plus or minus. So x is either greater than square root of 2, or on the interval x is less than negative square root of 2. Okay? So if we were to convert this to interval notation, we would get from 0 to negative square root of 2. Not 0. I meant from negative infinity to negative square root of 2. That's actually from this one. And from square root of 2 to infinity, we are increasing. Now to find out where we're decreasing, we do something crazy. We take our derivative and we set less than 0 because we're looking for when it is negative. Okay? So actually you end up getting 6x squared less than 12, x squared less than 2, square root both sides, square root both sides. Okay. And for this one, remember less than, you actually get the weird ones where it would be x is less than square root of 2, and you're going to get x is greater than negative square root of 2, which these intercept, so you can just move this over here. Okay, so if I were to write this in interval notation, it would be from square root of 2, negative style, to positive square root of 2, we are decreasing. And if you look at the function, it looks up. If you look at the function, it's drawn terribly. Now, if you look at the function, it actually looks something like this, where this would be negative root 2, and this would be root 2. So it makes sense that you're increasing, then you're decreasing, and then you're increasing once more. Okay? Not too bad. Not too bad. Okay. We aren't going to worry about this stuff for now. So, I'm going to talk more about when we talk about integration. So, we're going to call it a day. Enjoy.